Namaste, Anirudh. How are you? Yeah, I'm good. Welcome to the class. I'll be taking chemistry class for you, and today we will be taking about chemical reactions and equations. Yeah, is your parents around here? Okay. Hello, ma'am. How are you? Yeah, I'm fine. Good. Yeah. Okay. Okay. So he seems to get confused with the topics whenever he takes the test. Okay, I get that. Okay, yes, thank you, ma'am. I'll be addressing all those issues. Um, yeah, my name is Dr. P.T. Srinivasan. I have got more than 25 years of teaching experience to varieties of students at different levels. I have seen students with memory problems. Some students get confused with the topics whenever they go for the test, and some students tend to not to read certain topics whenever they find it difficult. Okay, so all these things will affect their overall performance in their final grade. Okay, so yeah, I'll be addressing all those things. Okay, thank you, ma'am. Yeah, we'll get into the topic. Hi, Anirudh. Let's get into the topic, chemical reactions. Okay. Okay, so you have studied chemical reactions, right? Yeah, good. Yeah. Is there any particular textbook that you have studied which has inspired you, or you have seen any movie which has inspired you? Yeah. Okay. Oh, you read MC Comics. Okay, that has inspired you. Okay. So you are a fan of all those superheroes. Yeah, good. I used to watch some of the superheroes. Yeah. Yeah, Doctor Strange. Yeah, Iron Man. I'm a fan of Iron Man. Yeah, that's good. Yeah, I've seen quite a few movies. Spider-Man, Ant-Man, Wonder Woman. Yeah, yeah, Black Panther. Yes, I enjoyed them. Oh wow, good. So we share some common things in the taste of the topics. Yeah, that's good. That's good. So you've got good memory. You are able to remember what you have seen in which movie and what was the character, etc. Good. Yeah. Now I'll teach you how to channelize that energy into your chemistry. Okay. No problem. I'll give you all my experience in molding you and giving you a tailor-made solution of how do you remember it easily. Okay, so at the end of this session you will feel that this problem of remembering and getting confused will not be there. Okay, yeah, good. Now let's get into the topic. So okay, what is a chemical reaction? Okay, the definition goes like this. It's a process where you have bonds will be broken and bonds will be produced. So this is what, suppose if you take an example of hydrogen combining with oxygen. Okay, now hydrogen has got a bond like this, oxygen has got a bond like this. Okay, and Anirudh, whenever you feel that I'm going too fast, or if you are not able to understand whatever I'm explaining, please feel free to stop me. Say, sir, please. Like that, I'll stop. Okay, you can make sure that you understand each and every step and the topic I'm explaining to you. Okay, good. Are we in sync? Yeah, good. That's good. Yeah, now this bond will be broken and this bond will be broken. Okay. Finally, you get what, when these two combine, you get a water molecule like this. You get a water molecule like this. Okay. Yeah. Sir, where is the other oxygen gone? We need to balance this equation. Oh yeah, you know balancing. Good. Okay, so balancing means you can take half of this to get one O, or you can take twice the time and give two molecules. Never mind. So we don't go into that now. So what is a chemical reaction? It is a breaking of bonds from what we call this as a reactant. Okay, and what is formed here is called as a product. Okay, so when we write a chemical equation, okay, so you write a chemical equation like this: H2 plus half O2 gives you water. Okay, this side we call it as the right hand side. Yeah, that's very good. That's very good. Okay, left hand side and right hand side. Now we can see this as an equation. Okay, both sides will have same number of atoms, etc. Balancing. We don't go into that now. We see the definition. So breaking of bonds between hydrogen and oxygen, and forming of bonds between oxygen and hydrogen like this. So that's called as the uh, definition of chemical reaction. So what happens during a chemical reaction? During a chemical reactions, you get atoms are rearranged. As you can see here, we had hydrogen and oxygen combined here, and these two are rearranged to get combined like this. Okay, atoms are rearranged and there is no new atoms are created or destroyed. That's very important. According to the law of conservation of mass. You have heard of law of conservation of mass? Good. Yeah, can you tell me what it is? Yeah, correct. Can neither be created, yeah, nor can be destroyed, but can be converted from one form to another form. Very good, excellent. Keep going. See, you are able to remember it. That's very important. Good. So based on that, here you have the hydrogen and oxygen forming water here. And the next point is the properties of the product. This one are usually different from those of the reactants. This one and this one are reactants, and this is product. This is product. These two are reactants. Okay. So how would they are different? Hydrogen. Can you tell me any property of hydrogen that you know? Yeah. Whoa. Yeah. Wow. Good. Yeah. Pop sound. Yes. When you introduce a burning splinter in a test tube which evolves hydrogen, it burns with a pop sound. Excellent. Yes, that is the property of hydrogen. And what is the property of oxygen? Yes, yeah, good. It's a supporter of combustion. Can you remember any experiment you have studied in your lower classes on that? Yeah, that's very good. That's very good. Yeah, candle lit is kept with an inverted glass tumbler. After some time, it gets put off because the oxygen present inside the glass cylinder tumbler is exhausted. Very good. Oxygen is a supporter of combustion. Hydrogen makes the burning splinter to burn with pop sound. But water, this is water. H2O is water. Water is a fire extinguisher. It doesn't support fire. So the property is different. So that is the next point, that is the properties of products is different from those of the reactants. Okay, you got it. Then the third point is energy changes often occur. Energy changes means some energy will be released. We call that as an exothermic reaction. Sometimes energy may be absorbed. We call it as an endothermic reaction. Okay. So again, this is based on the law of conservation of energy. Like mass we have here, the total energy should be same on both sides. Okay, we will see that in detail. Yeah. Now you are familiar with the definition. Very good. Very good. Yeah, now we'll see how do we identify a reaction, whether a reaction has occurred or not. Now, what do you mean by that? Say, for example, you take a plate, you take some carbon particles like this. So, this is carbon particle, okay? Carbon powder, you can say. Now, you take a cylinder, okay? You take a cylinder, oxygen cylinder, and then you blow the oxygen into this. You blow the oxygen into this. Now, what do you think will happen? You take a glass plate, you pour some, carbon, you put some carbon dust in this, and then you blow the oxygen into this. What will happen? CO2 will be formed? No. Just think very casually. Suppose you take a powder in your hand and you blow it. What will happen? Yeah, it will fly away. Correct. Same thing happens here. When you pour oxygen, the carbon particles will fly away. Nothing will happen. Nothing will happen. So how do you know the reaction has occurred? Good. So there are certain indications by which we can make sure that a reaction has occurred. So for this reaction to occur, we need some energy. We will see that later. Now what are the indicators of a reaction? So first one is the color change. In any reaction, wherever there is an involvement of color, the new substance formed will have a different color. Okay, for example, if you take rusting of iron, you have studied that? Yeah, that's very good. Corrosion. Yeah, in your chemical reactions and equations, you have studied corrosion. Yes, good. Here, the silver gray shining type of metal, pure good iron, get converted to reddish brown. So, this is an indicator that some reaction has occurred. The next one is evolution of some gas. Remember, not all reactions will evolve a gas, but wherever there is an evolution of a gas, we can say that the chemical reaction has occurred. Okay. Now, bubbles or fizzling shows gas is produced. Now, you take a test tube. You take a test tube like this, and then you pour some HCl into this. HCl is not green in color. I am just showing you for representation purpose. When you take HCl in a test tube, and if you put some zinc granules into this, after some time, if you shake, now you can see some gas will be evolved. Okay, this gas is hydrogen. Now, how do you check hydrogen? We saw it before. Yeah, correct. You introduce a burning splinter when it will burn with a pop sound. It will burn with a pop sound. So that is evolution of gas. The second indicator is evolution of gas. Good. Very good. Very good, Anirudh. You are really going very good. Now you see temperature change. The third one is temperature change. So the temperature of the reactant and the temperature of the product will be different, because some reaction heat is released, we call it as exothermic. Some reactions the heat is absorbed, we call it as endothermic. For example, neutralization. You have heard of the term neutralization? Yes, good. When acid reacts with the base, it forms a salt and an acid. Okay, I'll rub this so that you can, I'll write it here for better purpose. So you take an acid. Can you name this acid? Yes. Yeah, very good. Hydrochloric acid. And this one, sodium hydroxide. Yeah, very good. Very good. Now you have sodium chloride plus water is formed. Yeah, neutralization reaction. Correct, correct, Anirudh. Whenever an acid reacts with the base, it forms salt and water and heat is released. If you touch the sides of the test tube, it will be little bit warm depending upon how much acid and base you have taken. Okay, very good. The next indicator is precipitate formation. Whenever an insoluble solid, so what is a precipitate? A precipitate is a insoluble solid that is formed during a reaction. Okay, now if you take silver nitrate, you know, Ag is silver, argentum, silver nitrate. When you treat it with sodium chloride, you get silver chloride as a precipitate. It settles down at the bottom. Okay, then the next indicator is light or sound production. Light or sound production. Some reactions may involve emit light. You can see them as a dazzling flame or a scintillating flame or some type of luminescence or phosphorescence like that. Okay, I'll tell you all those words. I'm just trying to uh, make you familiarize with the indicators. Okay, then what you have studied this magnesium ribbon produces a bright white light. Yeah, you have studied that. Very good. In the beginning of the lesson. Very good. Correct. When you burn the magnesium ribbon in the presence of oxygen, it gives a white flame, scintillating flame. Yeah. Some light and sound is produced. That sound, can you tell me an example where a sound is produced? You know that. Yes. Just think of it. Any reaction which produces sound? You want a clue? Yeah, I'll give you the clue. It is a festival, okay, coming up sometime now in October and November. I don't want to specify the date, you will get it. Yeah, Diwali. Yes, correct. So when you play crackers, you get sound. Some of the reactions, they are all chemical reactions. The different colors that are produced in the crackers are due to these chemical salts that are being used. Okay, very good. Yeah. Yes, yes, correct. You have got. Can you tell me some colors that you have seen during the crackers? Yeah, yeah. Red, green, bluish green. Yeah, orange, magenta. Good. Yes, any color you can see. You can see a varieties of colors. Okay. Yeah, those things are examples of that. Then change in smell. New odor. Odor means smell may be produced during some of the reaction. Like when your food is spoiled, you get a decay smell. That is it. So these are the indicators of a chemical reaction. Okay. Yes. So far we have seen what is a chemical reaction and what are the indicators of a chemical reaction. Don't get confused with the indicators that we use in the titration. That is different. Yeah, correct. Yes, you are about to ask. You should ask. Okay, I have told you. You should ask me whenever you feel that you have a doubt, or whenever you don't follow what I am telling, or you want to share something, you can interrupt me, because I am here to make you understand and learn concepts in a much better way. Yeah, good. Okay, then we have the types of reactions. We have different types of reactions. The one, I'll first take you through the different types, then we will see the individual types. The first type is the combination type of reaction. Combination type of reaction, we also call that as a synthesis type of reaction. The next one is decomposition reaction. Decomposition reaction. Third one is displacement reaction. Single displacement reaction. You also have a double displacement reaction and combustion reactions. Okay, so we will see them one by one in not much detail, maybe a definition and an example. So what is a combination reaction? When two or more reactants combine to form a single product. Remember, single product is very important. Okay, so you have A combining with B to form AB. Okay, this looks small. You want me to zoom this? Yeah, I'll zoom this. Yes. Now you are able to see better. Yeah, good. Yeah, feel free, Anirudh. Feel free to tell me whatever is required. I'll help you out in understanding and making the chemistry as easy as possible for you to understand. Good. Now you see hydrogen and oxygen combining to form water. So this is an example of an element and an element combining to form a compound. Okay. So this is an example of a combination reaction. Usually it is also a synthesis reaction, because water is synthesized here. We call that as a synthesis reaction. So what is the key point here? The energy is usually released. Whenever a reaction occurs, energy will be released. That means the product will have lesser energy, which makes it more stable. We will see those things in detail later. Okay. Now the next reaction is decomposition reaction. So what is a decomposition reaction? A decomposition reaction is a single compound, remember, breaks down into two or more simple substances. That is, you take AB, A plus B. Yeah. Yes. Yeah. Okay, so you are asking whether it is decomposition is the reverse of combination. Yes, you can say in certain occasions, no in certain other occasions. But most of the time, it depends upon the energy and other factors, thermodynamic considerations, kinetic considerations, which you may not be very familiar at the moment. But for the time being, you can say that some reactions are reversible, some reactions are not. Okay. Now, if we take an example of potassium chlorate, when it is heated to form potassium chloride and oxygen. Okay. Now, this what is the salient features of this reaction? It requires heat, it's a thermal decomposition, and then light or electricity. In some form, you give the energy to the reactant to form the product. Okay. Then the third type is the displacement reaction. There are two types, single displacement and double displacement reaction. Here one element replaces the another element in a compound. Yeah. Yeah, you have a doubt? Yes. Which element will displace which? Correct. Very good question. That's a very, very good question. Now, a more reactive element, I am writing it here, a more reactive element will displace a less reactive element. Okay? Okay. How do you want to remember this? Okay, I'll teach you some shortcut to remember that. Okay? Maybe I'll give you some elements like this. Potassium. P is potassium, not phosphorus. Sodium, S, barium, calcium, PSBC, okay, and then you have chop. What is chop? Copper. This is Hg. You know what is Hg? Yeah, mercury. Correct. Very good. Hydrogram mercury. And then this one is silver, Ag. This one is gold, Au. This one is platinum. Okay, these are more reactive elements. Potassium. So PSBC chop. You remember this, PSBC chop. Now you also have in between something which I will give it you here, mesentyl. Okay, magnesium, aluminium, zinc, iron, nickel, tin, lead. Don't worry, I'll send you the detailed notes on whatever I am showing you here, I'm telling you here. I will send you the PDF of the class notes so that it will be easy for you. Even if you are not able to take down the notes, I will send you the PDF of the entire class notes and the video also for your revision purpose. Okay, that's very good. Now a more element will displace the, now zinc, this is zinc. Okay, Z is for zinc and this is copper. Copper is here. So I told you this portion will come here. Okay, now zinc will displace copper, so copper will come out and zinc will form zinc side. Okay, so this is the clue for a more reactive element displacing the less reactive one. Then the fourth one is the double displacement reaction or combustion reaction. These two are different. Okay, don't get make sure that you understand. This is a different reaction. This is a different reaction. I've just put it together because just to reduce the number of types of reactions. Okay, double displacement reaction. So what is a double displacement reactions? Exchange of ions between two compounds. So every compound will have two ions, a cation and an anion. Okay, so you have a cation and you have an anion. The cation combines with the anion of the other and vice versa to form the respective compounds. Okay, so here you have the silver will carry the plus charge, nitrate will carry the negative charge. Similarly here, so you get these two get exchanged and form a double displacement type of reactions. And then combustion reaction. So what is a combustion reaction? You burn something in the presence of carbon. Okay, like sorry, in the presence of oxygen, then you get carbon dioxide and water. So if you burn any hydrocarbons, you know what are hydrocarbons? Yes, yeah, okay, you can try. Now it's in the name itself, the clue is in the name itself. Yes, hydrogen and carbon, very good. Compounds containing hydrogen and carbon, like something like this, methane. Yeah, acetic acid, yes, good, it's an hydrocarbon. Yeah, okay, so you have methane, that's when you burn it in oxygen, it forms carbon dioxide and water. Okay, okay, so now let's summarize whatever we have studied so far. Types of chemical reactions. So what are the types we have studied? We have studied, yes, synthesis. What is the other name for synthesis? Combination. Very good, combination. Then next one is decomposition. Yeah, there are several types of decomposition, we will see that later. And then displacement, single displacement reaction, double displacement reaction. So here I have given only single, double is also there. Then combustion reaction, this is methane, CH4 giving you this. Okay, that's a summary. Now let me see if you have understood whatever we have discussed so far. I'll give you a quick question. Check your graphs. Okay, I want you to go through the question carefully and try to answer the question. Yes. I'll read out the question to you. Burning of carbon in the presence of oxygen is an example of dash reaction. That is, if you take carbon plus oxygen to give CO2, this is the product. Now, what type of reaction is this? Read the question carefully, take your time and answer the question correctly. Okay? Yeah, I'll give you maybe a minute time. Yes, it is a combination type. Looks like combustion. Okay. Oxidation. You have heard of oxidation? Not very sure. But A and B are, you are telling me, A and B are correct. Then, you want to make a guess? Yeah, you can make a guess. Since A and B are there, you want to go for the option D. Correct. This is option D. It's an example of a combination reaction, element-element combination reaction. It's an also a combustion reaction where you will have heat is released in exothermic or reaction, and then it's also an oxidation because there is an addition of oxygen to the reactant, and therefore it is all of the above. Very good. So yeah, I hope you have understood the concept of what is a chemical reaction and what are the indicators of a chemical reaction and what are the general types of a chemical reactions and how do you classify them based on the certain parameters. Okay, good. Yeah, ma'am. Yeah, yes, ma'am. It's good. Yeah, he was very obedient and he was listening and it was very interactive. He was answering my questions. Yeah, he also asked doubts. Is there any specific concern you have, ma'am, about Anirudh? Yeah? Okay, 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 ma'am. So, he doesn't read focusedly, like he doesn't sit for a while and read. He just gets off. He's very lazy. That's very common with most of the students, ma'am. Yeah, that's not an issue. They are good, they know their responsibilities. Once we make them to understand their responsibilities, they'll really do good. I'm very happy about Anirudh, ma'am. He was able to interact well and he asked me questions. And for the last question I asked him, he was very meticulous and he was going systematically and approaching the question and trying to answer the question. That was very good. And he made the guess, which was really superb. I should appreciate that for him. Yes, ma'am. Yeah. So it depends, ma'am. Like if he's got problem with some topics, we can decide the topics on which he's got issues. I can take classes on those topics. So depending upon your requirement, we can design the number of hours that you want to have. Like if you want to go for selective topics, I can tell you, if you can let me know the topics, I can tell you the number of hours that is required for those topics. Or if you want to go systematically for all the lessons, then we have a different type of approach to that. So we have got tailor-made solutions for every requirement, because students are different and their understanding, their way of listening are all different. It depends upon so many factors. Okay, so based on that, we can tell you how much is required for him to interact. And rest assured, ma'am, I'll make him to do whatever he wants to do or whatever he can do. Okay, I am very confident that I can do it because he was very cooperative, he was very obedient, he was listening, and he was asking questions. And lastly, he was able to approach the questions. He's got all the qualities to be a good student and have the attitude and aptitude to go for entrance examinations after his board exams. So we can really do him well. Yeah, he was good. Yes, that's good. Well, I can expect that. Good, ma'am. Okay, so the discount part, yeah, you can talk to our academic counselors are there. They'll get back to you on. You can speak to them on the number of hours that you want, uh, like all those details, fee details and all. They'll tell you. Uh, Now, this is very important, ma'am. Nowadays, students need mentoring, ma'am. Teaching subject is one part of the online class, and mentoring the student is more important for each student, because every student has got some unique, I won't say problem, issues in improving their scores and doing well in their final exams. Okay, so mentoring, and I'm a very experienced person. I think you know that before. I'm got more than 25 years of experience. I can really understand the problem of the student and groom them accordingly to improve their scores and do it. Okay, so yeah, I look forward to mm, uh, your feedback, ma'am. I want your feedback on whatever you feel about my class, because it requires, although I have got vast experience, as I told you, every child is unique. Every child is unique. So the child perspective of how a student how a teacher can improve uh, the uh, how a teacher can improve their way of interaction, at least for them, not for others. Okay, so I want you to give a feedback on today's class, what Anirudh felt about my class, and whether he was able to understand. I mean, I was able to understand that, but I want your feedback along with your son's input also, and give me a comprehensive way of how, where I can improve my uh, teaching to Anirudh, and make the feedback very candid and meticulous, ma'am. It's very important, because we are very serious about working and improving our way of teaching and other things suiting to individual students' requirements. So I want your feedback at um, you can answer like whatever way you like. If you want, I'll give you some template, um, something like this. If you we have a I'll send you a questionnaire. If you want, you can answer those questionnaire. It will be very much useful to me, because um, we are very serious about, as I told you, in improving our uh, quality of teaching students. Okay, ma'am. So I want you to go whether it was awesome or great or good, or it could have been better. If it was great, what has worked you in my class, and if any of these what is did not work out for you, then how can I make this better? Like, if whatever concerns that you have. Okay, this part you need not have to be very particular. So what I can improve, what I can improve. Okay, in making your this learning process a much better one and a more useful to your son. Yeah, thank you, ma'am. Thank you for your time. Anirudh, have a great day. You did a very wonderful job. I hope to see you again, and I promise you that I will take you through all the hurdles and make you to get successful in your final exam. Okay, yeah, bye, goodbye, see you, take care, all the best to you. Have a good day.